Hello A2, welcome to Ways of Studying the Brain. So we're going to look at the different ways that psychologists study the brain, which I know might be a bit of a shock for some of you with the title, but there we go. So there are 4 different types of studying the brain that are mentioned on the specification that we need to be aware of. And they are Postmortem, fMRI, EEG and ERP. First starting off with the Postmortem then. The participant, I'm sure you've heard of postmortems before, the participant is dead. 1 second, let me see if I can... Okay. The participant is dead. Generally what has happened is they've been identified as having some kind of abnormal behaviour which is in some way related to, they believe related to some kind of brain damage or some kind of problem with the brain. And we wait until this was pre any kind of technology, so it's before the 1900s. We would just have to wait for someone to die, and then we would chop them up and we would look at their brain. And the postmortem, so the official kind of way of talking about it, is that it looks at underlying neurobiology, so it looks at the underlying structure or biology of the brain, so neuro meaning brain. Different examples: Tan was a patient with problems with speech. He could only say the word tan. When he died, Baroka cut him up open, had a look inside and saw that there was lesions on this particular area, which then, surprise surprise, became Baroka's area. HM, who I think that you probably can all remember. I think you've looked at him with Andy. When he died, a post-mortem was conducted on him and it was identified that there was damage in the hippocampus and that affected his memory. So remember, you can link all of these to things that we already know about, so I don't know if you can remember as well when we looked at the, if you can remember looking at the murderers in class and their brain structure and how that influenced whether they were violent or not, the kind of crimes that they committed. It's a diagnostic tool used to identify various kind of vulnerabilities in the brain structure to mental health conditions. So we've looked at people with depression, people with schizophrenia, and we've been able to identify certain kind of unusual or abnormal neurobiology within those people. Generally what happens is we would compare the brain with a neurotypical brain, so you'd never say a normal brain because normal isn't a very scientific, very accurate term. It's also quite a judgmental term, so you would talk about it being neurotypical, so that means the traditional typical sort of brain that we would have. You'd compare the two, so it'd be like a control brain and an experimental brain, and we would look for the differences. A post-mortem allows us to access the much deeper regions of the brain that no other scanning methods can help us access, because of course we don't need to worry about going too deep, and we can cut right to the bottom of the brain. Functional magnetic resonance imaging, fMRI, measures the hemodynamic response, which essentially means that when the brain is in use, like any other part of the body, when neurons are firing, then more oxygen is needed because that part of the body is more active, and therefore blood flow increases to that area to get more blood to that area of the body, and that's the same with the brain. So fMRIs measure the blood oxygenation level dependent signal. So that means that more blood, more active area of the brain needs more blood. So they use a bold signal. fMRIs are one of the first kind of imaging techniques that we are going to look at after a post-mortem, and they create 3D images of the brain. And generally you would find that participants were given a particular task, where it was compared, and they were given a control state, so they would look at a stimulus for 30 seconds and then they would experience a control state, so they'd look away, and you could compare the two differences. Something that would be relevant, particularly for the evaluations, is how much of what we know might be wrong because of fMRIs. So they aren't very reliable at all or very valid because, and there's evidence here of they scanned a dead fish and found that it had brain activity, which is probably not the case. So it's quite an interesting one, especially if you're kind of looking for the higher grades. You could have a read of that article, and just because it's quite interesting, because they scanned a dead fish, and then could justify it as psychological research. EEGs, the big thing in quotes is a direct reference to a definition from the Mark scheme. So a recording of general brain activity usually linked with states such as sleepers arousal. So the way that I remember it for this one is post-mortem dead, fMRI blood, and then EEGs are electric. So small electrical charges, as you know, you think about action potentials, they're electric in neurons, that's how they pass messages around the brain, so you can kind of link all of that together. So small electrical charges are detected by electrodes. So I'm sure you've seen somebody have an FM or an EEG with electrodes placed on the brain, and then these electrodes, or the activity measured by the electrodes, is graphed over a period of time, and those graphs are called EEGs, and they indicate the level of activity in the brain. And then it should say electrodes placed on the scalp. So small electrical charges made by the brain are detected by electrodes, and then they graph that over time, and that looks at the activity levels in the brain. The most important thing about EEGs, it looks at the general brain activity, and it's usually linked with particular sleep states, such as sleep, and it's used as a diagnostic tool for arrhythmic patterns, so unusual or abnormal patterns. Epilepsy is a good one because you can see the spikes in electrical activity. Alzheimer's, or generally people with some kind of brain damage, you will generally find they have slower brain waves, slower brain activity. And EEGs are really good at measuring different types of waves of sleep. As we fall to sleep, you'll see all the different kinds of sleep, and the EEGs can measure those. And I would encourage you, I haven't put it in this year, but last year with the A2s, I did ask them to look at brain waves when you sleep, so delta, beta, theta, I think it's something like that. And I would encourage you to do the same, but only if you're going to access the higher grades. And then we have event-related potentials. Event-related potentials use EEGs. So the same problems that are with an EEG come with an event-related potential. You still put electrodes on the brain, those electrodes are the same thing. However, ERPs, event-related potentials, are elicited by specific stimulus. So EEGs record the general activity of the brain, whereas ERPs look at specific stimulus presented to the participants. So what they do, exactly like we talked about, they take multiple, they present a stimulus to participants, they do it multiple times, collecting data through EEGs, through electrodes, and then using statistical averaging techniques, which you don't need to be aware of, they can average out any extraneous neural noise. So that means that they would show them, experimenters would show participants a stimulus, and they do it repeatedly over and over again, and they would average it out. So if there are any if we only did it once, say for EEGs, and we saw something unusual, we wouldn't be able to work out if it's extraneous or if it was relevant to the experiment. So for example, you would show somebody a stimulus and several different parts of the brain might light up. However, if you do that again and again and again, some of those parts of the brain will disappear, being lit up if you then average it out, because they only happened every now and again. And that could be because a fly kept flying past, they were distracted by the noise, they got distracted and thought, oh, what do I want for dinner? Whilst concentrating on, they could have been very tired, so whilst concentrating on the problem, they'd just been given all the stimulus to look at, their minds would start to wander, they might feel, they might suddenly want to sneeze, any of those things. So if you do present it over and over again, you can average out any extraneous neural noise, so any background neural activity that isn't related to the stimulus, and you can be pretty confident that the information that you've got, the part of the brain that you've pinpointed, is specifically related to the stimulus that you have just presented to the participants. So EEGs, general electrics, ERPs, statistical averages. So postmortem dead, fMRI blood, EEGs electric, ERPs maths. Simple as that. And then if you get really, really stuck, there is another person who probably makes far more sense than I do on tutor2u.net, and they have some bio psychology topic videos that you can listen to, and they've got loads of other resources as well. Joseph is excellent. AO3 for ways of studying the brain. You've got 4 different types you're going to talk about. We're going to make it nice and easy. You're going to evaluate them on each one of these 3 things. So invasive, non-invasive, invasive, temporal resolution and spatial resolution. If you think about whether something is invasive or non-invasive, invasive means do they have to be cut open? Does any equipment have to be placed inside the body, placed inside the brain? Do they have to go under surgery? Any of those things. So fMRIs, EEGs and ERPs, do you think they're invasive or non-invasive? They just place electrodes on the skin, so nothing happens there. fMRIs are a little bit more scary because they are placed in one of those big tubes, so I'll show you in class, but there'll be a big tube that they get rolled through. Think about if you've ever watched House, that's the kind of thing that that's an fMRI. But actually nothing really physically happens to the body. It's a bit scary, but nothing's inserted, nothing's cut open, anything like that. However, postmortems, what happens there? Are they quite invasive? So that's an argument for that one. Spatial resolution means the smallest measurement the scan can detect, so the smallest amount. fMRIs, it's 1 to 2 millimeters. EEGs, it's 1 centimeter, and obviously ERPs, because there's some sort of thing, it's also 1 centimeter. So they can't pinpoint with a great deal of accuracy, EEGs and ERPs. They're just the general area, so you have to question whether that supports the validity of the measurements that are made. So can we trust the measurements that are made? Whereas fMRIs, they can be much more specific and pinpoint things more, activity more specifically, so that increases the validity, because if we say this part of the brain is involved in this process or this thing, then we can be confident that is the case. And temporal resolution, so the precision of a measurement with respect to time, so a bit like temporal validity but temporal resolution. There is a hypodynamic lag, so that means between the activity starting and the body realising and responding to the area's need for blood and, well, oxygen and therefore blood. So there can be a 5 to 6 second delay on fMRIs, which is huge when you think about how quickly the brain works and how quickly we think and then stop thinking about things. Whereas EEGs and ERPs, it is milliseconds, so there is much less of much higher temporal resolution, much less of a lag, but it wouldn't be hypodynamic because that's linked directly to fMRIs only. Hypodynamic, I don't know. Linked directly to fMRIs, whereas not EEGs and ERPs, because they don't look at blood at any point. Okay, so that's how you would evaluate those, and the same with postmortems. Obviously, it can be incredibly specific as to what area of the brain it is. However, temporal resolution is non-existent. We can't present somebody with a stimulus and then see how they respond to it when they're dead, because they aren't going to respond, unless, of course, maybe they're that dead fish in the fMRI. Okay. And then underneath there is there's a reference to where I collected some of that information, so you can have a little read of that if you want to, and also biopsychology, studying the brain's evaluations. So again, Joseph has put together a nice interesting web page, so if the information I gave you wasn't detailed enough or you didn't understand it, you were still confused, you can have a look on the website as well. But I'd remember invasive, spatial resolution, temporal resolution. Those three things cover you to evaluate both the strengths and weaknesses of 4 things, so they save you memorising 8 individual evaluation points, which is quite handy. Any questions, please get in touch with me, otherwise I will see you at your next lesson. Thank you very much.